Hello everyone. In today's video we are going to discuss about the ICSE 7th grade's chapter of physics, chapter number 2, motion. So all the things around us that we see in our daily life, some are there in the rest, some are there in the motion. So there are the different kinds of things we are watching, that is roads, houses, trees, vehicles, people moving on the road. So sometimes we get confused in all these things, that which other things are there in motion and which are at rest. The very first thing that we'll discuss about, that is the rest and motion. What is rest and what is motion? So rest and motion, these are the two terms, and these two terms are related to each other. So motion is relative. So we will discuss what is rest and what is motion. Suppose if a particular object is not changing its position with respect to its surrounding. For example, you are sitting in a room, you are sitting at one place and you are not changing your position with respect to the things around you. Surrounding means the things that are lying around you, that is maybe your bed, it may be your fridge, is it chair, table, whatever the things around you, you are not changing your position with respect to the other things. That means you are at rest. So if the body is changing its position with respect to its surrounding, then it is said to be in motion. Means when you start walking in the room, then you change the position with respect to the other things. So it means you are in motion now. So same way, the things which are moving, that are said to be in motion, and the things that are at stationary, that are said to be at rest. So sometimes we are not able to distinguish that which is the body which is in state of rest or which is in motion. So mean these two terms are related to each other. Motion is relative. For example, here they given the example also, motion is relative. The background appears to be moving relative to the motorcycle. If you see in the first diagram here, then this motorcycle is moving but stationary, the surroundings, is it? If you see here now, the motorcycle appears to be moving related to the background is moving now, but stationary can be the motorcycle, is it? These two things are related to each other. Means if you are sitting in the bus, with respect to the surrounding of the bus, you are at rest, is it? But the surrounding outside, you are in state of motion, is it? So it means these two terms, rest and motion, are related to each other, is it? So that you have to keep in mind, that these two terms are related to each other. So in the same way, let's discuss about the types of motion. There are the different types of motion. So we will discuss about some of these types of motion. So very first thing is the translatory motion. We are having translatory motion. Translatory motion is what the motion of the body in a straight line or in a curve. That is called the translatory motion. So based on this, it is divided into two types. Translatory motion is further divided into two categories. That is rectilinear motion, rectilinear and curvilinear. Rectilinear and curvilinear. So it is clear now from the definition itself. Rectilinear means motion in the straight line. So it is there in the definition of translatory motion, that motion of the body in a straight line or either in the curve. So it is divided into two parts, rectilinear and curvilinear. If motion of the body is there in the straight line, then it is said to be rectilinear, and if motion of the body is there in the curve, that is curvilinear. Rectilinear motion in the body, for example, a vehicle is moving on the straight road, that is having that linear motion, rectilinear motion. If vehicle is moving on a curved road, then it is having the curvilinear motion. Here they have given the example of when the water is coming out of the tap or out of the pipe, water pipe, then it is having the curvilinear motion. Well, it will go straight also and it will make a curve also. That is a curvilinear motion. Then we have The rotatory motion. Rotatory motion. Rotatory motion is what? Motion of the body when it rotates on a fixed axis. Rotates or spins on the fixed axis, like the motion of a fan. The tires of the vehicles moving on the fixed axis. There are so many examples of this rotating motion. Then we have spinning top, is it, drills, machines. They all are having the rotatory motion. Then we have the oscillatory motion. Oscillatory motion. Oscillatory motions of the body is, what is the oscillatory motion? The to and fro motion. The to and fro motion of the body along a fixed point, that is said to be the oscillatory motion. For example, if we take the example of a simple pendulum, pendulum is having the fixed spot and there is a string along with which a metal bob is there. So this pendulum is moving to and fro, is it? So this is going like this, is it? Going and coming back. This is the main position and these two are the extreme position. So motion of this swing, right? Swing is one of the example in which there is the oscillatory motion, right? So the periodic motion about the main position of the body, that is said to be the oscillatory motion. So vibrational motion, it can be said the vibrational motion also. The vibration of the star, guitar, tabla, drums, they are making the oscillations, and their strike, they are producing the oscillatory motion or vibrational motion. Then we have the circular motion. Circular motion. Circular motion. So motion of the body in a circular path, that is said to be the circular motion. When you are whirling something in your hand, like you take a stone and tie it with the string and whirl it in your hand, then it is having the circular motion. Position of the body keeps on changing, is it? But distance traveled in this case will remain same only because it is moving in a circular path. So distance traveled in the circular path is equal to the circumference of the circle, that is equal to 2 pi r. This is the distance traveled by the body in a circular path. The ferry wheel you all have seen, this is having the circular motion. So don't get confused between circular motion and rotatory motion. In rotatory motion, the position of the body does not change. But in circular motion, the position of the body continuously keeps on changing. In rotatory motion, you have seen that body is rotating at a fixed point. In circular motion, you can see if the Ferris wheel, if you see the different cards of this Ferris wheel, it is changing its position, is it? These are the cards of this Ferris wheels and it keeps on changing its position. So don't get confused between the rotatory and circular motion. Then we have the periodic motion. Periodic motion. Periodic motion. So motion of the body which repeats after an equal interval of time. That is said to be the periodic motion. For example, the day and night we are having, is it? The motion of the sun, is it? Motion of the moon, is it? That are all are periodic. The motion of the hand clocks, is it? Hands of the clock, that are periodic. So there are the different types of motion. You can do some activities and categorize all these motion into different categories, or the types of motion that you see in your daily life. So periodic motion, repetitive motion must be repeated at a fixed interval of time. This you have to remember. Then we have the simple pendulum. Simple pendulum. Simple pendulum, as I have told you already, it is having the fixed pole and a string is there which is having a metallic bob. This is the string of this simple pendulum, and from the fixed port to the center of gravity of this metallic bob, this is called the effective length of this string, effective length of this pendulum, the distance from the rigid spot to the center of gravity of this bob, that is called the effective length of this pendulum. Okay, then when this pendulum will complete its one oscillation, that we'll see now. Okay, so this is, then the pendulum is at rest, it is staying vertical, then this position is the pendulum is called the mean position, right? This is said to be its mean position. When the pendulum is at rest and with its string vertical, then it's said to be its mean position. When we move this pendulum, it goes like this to the first extreme and then to the second extreme. So these two positions, like A and B, these two positions are called the extreme position of the pendulum, right? These are called the extreme position. So when the pendulum will complete its one oscillation, so that one oscillation will be completed in two ways. They have given here also. So we will see here, this is the mean position and these two are the extreme position. For example, this position is A and this position is B and this is C. So if the pendulum, if we start taking its oscillation from A, then it will go to B, and from B it will again come to A. Then we can say that its one oscillation is completed, right? If we starting from A going to B and coming back to A, then it is said to be one oscillation. Or if we start from the mean position, from mean position it go to the first extreme, come back to the mean, go to the second extreme and come back to the mean, then it's said to be its one oscillation. So this should be clear in your mind. So this is said to be the one oscillation. Either it will be completed in two parts, in going from one extreme to second extreme and coming back to again first extreme, or either it is completed in four parts: first part, second, third and fourth here. So this is how its motion will be completed in four parts. That is called the one oscillation of the pendulum. Then we have the terms related to the pendulum. Then very first term is the time period. Time period, the time taken to complete its one oscillation, that is called time period of the pendulum. How much time it's take to complete one oscillation, that is said to be its time period. So time period, it depends on the length of the pendulum. Time period is directly proportional to the length, you can say square root of length. It's actually, if it increases, the time period will also increase. If length increases, time period will also increase. So time period does not depend upon amplitude, right? Amplitude is what? Distance on the either side of this mean position, right? So these are this is the amplitude, distance on either side from the mean position. This distance is called the amplitude of the pendulum. So time period doesn't depend upon the amplitude. Then third, time period does not depend upon the mass, right? Does not depend upon mass of the bob. Time period is not depending upon mass of the bob. So these are some factors. So time period only depending upon the length of the pendulum. Then we have the seconds pendulum. Seconds pendulum is what? The time period whose time period is 2 seconds. Pendulum with the time period of 2 seconds is called the seconds pendulum. So second pendulum we can make by ourselves, that is by keeping the string length equal to 99 centimeter, close to 100 centimeter, means it should be approximately 1 meter length of the string, and it approximately take 1 second to go and 1 second to come back to main position, to one extreme to other extreme, means it is taking 2 seconds to complete its one oscillation, right? These are the extreme position, first and second. It will take 1 second to go, 1 second, and come back 1 second. So it will take, to complete this one oscillation, it will take 2 seconds. So time period of the second pendulum is 2 seconds, that you have to remember. So they have given one numerical also. The simple pendulum makes 20 oscillation in 24.6 seconds. Find the time period of the pendulum. So 20 oscillations are there in 24.6 seconds. So one oscillation will be completed in 24.6 divided by 20. So this will give us 1.23 seconds. That will be the time period of the simple pendulum. This is a simple example. Then we have the speed and velocity. Speed and velocity. Speed and velocity is what, when we describe the motion, we say that one body is fast and one body is slow, and the slowness and fastness of the body is basically, we are telling up from the two quantities, speed and velocity. So speed is what, the rate of change of motion or rate of change of distance. Rate of change of distance means speed is equal to distance upon time. Rate of change of distance, and velocity is the rate of change of displacement. So it means displacement over time. Velocity is the displacement over time. So we will discuss about what is distance and what is displacement also later on. So if we talk about the units of speed, distance is measured in meter and time is measured in second. So meter per second is the unit of speed, and velocity is again measured in, displacement is measured in meter and time in second. So it is having the same unit as speed, meter per second and meter per second. This we are denoting with V, and this we are denoting with the V arrow, because it is having only magnitude, and this is having the direction also. It's having magnitude as well as direction. Magnitude and direction, it is having the both. So that's why we are putting an arrow on this, because this is the vector quantity. It is represented both with magnitude and direction. So speed is equal to distance over time, and velocity is equal to displacement over time. So that you have to remember. Units we have discussed. Average speed. Average speed means, average speed is the total distance traveled over total time taken. If the body is traveling with the different speeds, then how to find the average speed? Total distance traveled and total distance over total time taken. Total distance traveled over total time taken. This is how we can find the average speed. Then there's some examples based on this speed. So we can apply the formula speed is equal to distance over time. That is the formula to solve these examples. School bike covers distance of 90 meter in 15 seconds. Find his speed. Distance is 90 and time is 15 seconds. So it is 6 meter per second. That is the speed of that boy. So these are the simple examples that I have given here. Then we talk about the displacement. Displacement displacement is what? Suppose if body has to move from A to B, then it follows some certain path. It goes like this, and this total path traveled, that is called its distance. How much path it has traveled, that is called its distance. And the shortest distance between initial and final point, this shortest distance is known as shortest distance between initial and final point, that is called the displacement. So that is the difference between distance and displacement. Distance is the total path traveled and displacement is the shortest distance between one's first and second position. So here they have given the examples. The body is traveling in straight line, then A to B, it travel x, then x will be the displacement, because this is the distance between initial and final point. If body cover 4 meter in A to B, and from B to C it covers 3 meter, then displacement will be this shortest distance. This will be the displacement, shortest distance. Then like this, if the body is going, then this will be the total distance traveled, and this shortest distance will be its displacement. This you have to keep in mind, what is the displacement. Velocity we have covered already. Displacement over time, that is called the velocity. So based on this velocity, there are the examples given that you can solve. Then we have the uniform and non-uniform motion. Non-uniform motion. Uniform and non-uniform motion is what? So motion of the body at any time is described by its velocity. So this includes its speed also and the direction of motion also. So motion can be defined by the help of its speed. Speed remain constant and direction remains same. If velocity of the body is remaining same with respect to the time, then it is said to be moving with the uniform. Is it uniform motion? And if the velocity of the body is changing, then it's said to be moving with the non-uniform motion. So uniform motion example is a vehicle moving on the straight road. It is constant speed. Aircraft or a ship traveling on a straight course, is it that they are having the constant speed and they are having the uniform motion. So if the body is changing its direction, then it is moving with the variable velocity, so it means they are having the non-uniform motion. For example, the vehicle moves through a straight road and but a crowded road. On the crowded road we have to change the direction also and speed also, as it velocity also will change it, keep changing. And in circular motion we say this, I have told you already, that each and every point this circular motion, the direction of motion will change, so it means velocity will change, so it is having the non-uniform motion. So when you walk through a crowded road to the marketplace, then you have to make a small changes in your speed and direction also, so it means you are having the non-uniform motion at that time. So this is what about the second chapter. Okay then, thank you.